In this video, we're going to do a couple of book problems. So exercise 7 and 8. So this is problem number 7 in your homework. Identify each of the marked points as being an absolute max, absolute min, relative max, relative min, or none of the above. Okay, so if it's not one of those, then just none of the above. All right. So the points that are marked, these are my points that are marked. So I'm going to identify each of those. So I'm just going to start and go from left to right. So with A, looks like this point is the lowest point. The only problem about this point here is that when I look at it, it's not defined. Okay, so it would be the absolute minimum here, except for the fact that it's actually undefined at the A value. So if I try to plug anything in, it's just undefined. So there's no relative max, relative min, absolute max, or absolute min. The next point here, B, this one actually looks, if I drew like a horizontal line here, it looks to me as though that's the highest point on the whole graph. So not only is this a max, it's an absolute max. If you want to call it a relative max, that's fine too, because technically it meets the criteria for relative max. Okay, so a absolute max is a special type of relative max, is the biggest of all the maxes. Okay, that's the absolute max. But remember, the definition of relative max is that it's the highest y value in some interval of x's around that x value that produces the largest y value. So whenever I look at the values around this, clearly that's the highest output given those x values in this little range, right, or in this little domain right here. Okay, so technically, if you're an absolute max, then you are a relative max. Okay, but if you are a relative max, does not mean that you have to be a absolute max. Okay, so sometimes you kind of can think about it like in terms of like species. So if you are human, then you are a mammal, right? But if you are a mammal, then you're a human, that's not true, right? That's not, I can find a counterexample. How? I can say, what about a dolphin? A dolphin is, say, if you're a mammal, well, a dolphin's a mammal, so we satisfy the hypothesis, right? Then you're a human. Well, dolphins and humans aren't the same, right? So it doesn't work both ways. It's not an if and only if statement. So I'm just saying, if you're a relative max, then you're a relative or absolute max. That's not always the case. But if I do say if you're an absolute max, then you get relative max for free. Okay? So sorry to harp on that so much, but I just trying to stress that for you, make sure you understand it. This next one here looks like it's the lowest point. Not only does it look like the lowest, it looks like a cusp too, right? This is a relative min. Okay, relative min here. Remember, critical numbers give us a list of possible relative max or relative mins, but it doesn't guarantee that it's a relative max or min, right? So that's a cusp right there. That looks like the relative min, right? This next one here, this is interesting. Why is it interesting? Well, it looks like the highest y value around the place, but then you start thinking about it. Well, what is the y value? Whenever I plug in this value, what does it output? It actually outputs does not exist, right? So it does not exist here. It's undefined. So is there an absolute or relative max here? Nope, there is not. It's undefined at this point. So there's none. So don't let that trick you, all right? And so it's undefined. Why is there none? It's undefined at that point. If you can't plug in the value, there's no y output. Remember, it's the largest y value in some interval of x's that I plug in, right? So We can get infinitely close to that maximum, but we never obtain it. Okay, the next one here, well, this one doesn't look like anything at all, because on this left side here looks like it's values that are bigger. Well, in order for it to be a min, on the right side, the values would need to be bigger, right? However, on this side, it's negative, so it's smaller on that side, so that doesn't help us out at all. So this is actually another none here, okay? Down here, we've got a defined point. It's a relative minimum. All the y values around it are bigger, so this is the smallest one, so it's the relative minimum. Now, why is it not the absolute minimum? Well, even though it's the lowest one right here, what do we see? We could actually find a y value that's smaller over here, and it's actually defined at that point, okay? So this isn't the absolute minimum, okay? So you always draw that line, see if there's anything above or below it, and that kind of helps you figure out if there's actually a higher or lower extrema. And then here at the endpoints, we need to always check our endpoints. If they are defined, this one is defined versus that one that was not defined. It was undefined. And so that is a relative maximum. All the y values around it are less than it. Okay? All right. Let's go on to this problem right here. Evaluate f prime, so the derivative, at the points indicated on the graph. So it looks like we have 1 point indicated on the graph. It's 0, 2. So what do I need to do? I need to take the derivative to get the f prime. And so the derivative, this is homework problem number 9. How do I do this? Well, it looks like a quotient, so I'm going to use a quotient rule. So how do I do it? Low d high minus high d low all over the square what's below. So low is x squared plus 1 times d high, the derivative of 2 is 0, minus high, which is 2, times d low, the derivative of x squared is 2x plus 0. So x squared plus 1, the derivative of 1 is 0, derivative of x squared is 2x. Okay, all over the square what's below, x squared plus 1 squared. Now I need to simplify. If I multiply something by 0, that goes away. If I take this negative 2 and I distribute in here, I get negative 2 times 2x is negative 4x. Okay, and then divided by this right here. All right, now, what do I want? I want to evaluate f prime at the indicated points. F prime of what? F prime of x. So I want to plug in the x value, which is 0 for this particular problem. And so I'm going to take f prime of 0. I'm going to plug it in. Everywhere is x, I'm going to put a 0 here. So 0 times 4 gets me 0 in the numerator. This is 1 in the denominator. 0 divided by 1, spoiler alert, that is 0. Okay, if I take nothing, I cut it into one piece, that's still nothing. All right, so this is telling me that the derivative, the slope of the tangent line at x equal to 0 is 0. So the slope is 0, all right? So that's how I evaluate that, just like that, okay? And then you can draw a pretty little picture there. All right.